All right, ready, go. Let's try to simplify that one right there. Okay, so yeah, this one, I think I've seen everybody. 5 root 5? Yeah. I saw you headed that direction. 5 root 5. Okay.
Not going to be 8 in and moon is radiating down. Okay, so that's what you get. That's what we get.
All right, ready, go. Try that one. Okay, remember this is called rationalizing. Yes, you are. There we go. Yep, these are all looking really good. All right, this is super good. Okay, Rosie, Sarah, Deacon, yep, that's all good. You're almost there, keep going. Okay, Anders and Colby, yep, I think that looks good. Did you get it? 7 root 3 over 3. Yeah. Okay. Okay, you guys are doing really great so far. Should be 7 root 3 over 3 after you've rationalized. Okay. Good.
He's actually so
Both I and that's why I said you could do.
All right, ready, go.
Can you scoot over a little bit?
No. I need an eraser right now. Right? Sorry, I didn't mean to. Yeah, I'm so sorry. I got 2.
Oh, thanks. No.
Matt recognized something cool up here. Matt, would you mind mentioning the terminology? Hey, listen up, please.
Listen up.
Matt saw this as the difference of 2 squares. Do you see that? This is that pattern of the plus-minus pattern we talked about with factoring. This does end up being the square root of 9 minus the square root of 3 plus the square root of 3 minus 1. These 2 terms do add out to be 0. Square root of 9 is 3, minus 1 is 2. Question?
Where did you get the minus 1?
When I foiled, when I did my lasts, positive 1 times negative 1. Sarah, is that okay?
Yeah, I just added.
Okay. Yeah, remember FOIL is always multiplication. So guys, listen up. So far, this has been all pretty old stuff that you've... Hey, listen, Kyle. Thank you. So far, this has been pretty old stuff that you guys have done. We've been doing this for quite a while. What we're going to do now is some of the newer stuff that we did yesterday. So take your time, make sure you're doing this the best you can, and we'll see how it all goes. Okay, ready, go.
I'm sorry, I didn't mean to.
Because this is new, I want to make sure that we are super duper solid, because I'm going to start throwing some somewhat more challenging ones at you here, leading up to kind of where we finished last time, and then we'll practice with that too. Do you guys see how the radical is all by itself on the left side? There is stuff in there, but the radical is all by itself. Folks, hey, just watch, listen and watch, okay? So once the radical is by itself, what you can do is you can square both sides. The goal of that is to get rid of the radical. We want to get the stuff inside the radical out. So this is going to cancel here and here, leaving me with 6x plus 19 is equal to 49. So you subtract 19. You guys all did a nice job with this. 6x is equal to 30. Divide both sides by 6. You get x is equal to 5. Please remember that with these types of questions, you have to check. It's not just sort of a nice optional thing. 5 might not work. I haven't made any mistakes, but 5 might not work. So here's my check of 5. Checking 5 would be square root of 6 times 5 plus 19 possibly equals 7. Notice how I'm checking it in the most original form of the equation. This gives me square root of 49 possibly equals 7. And of course, square root of 49 is 7. So it does check. So yes, that is the solution of this equation. That good? Let me throw some other ones at you here and see how it goes. You are doing a really nice job so far. Okay, so here is this one right here. Let's go with...
I was going to
Yeah, no, it's plus. Square.
What's 9 plus 7? Go that way. Oh my God. Where'd you guys get it? Oh, it's in the game.
Let's go.
Excuse me, Morgan. That's what's next my room.
Oh my goodness!
You see how...
Okay. Here's what you do. Oh, you added, no, that's
Totally ignoring
that's very positive.
No, because it should be in parentheses. No,
So you scoring the radical anyway, that's cool. But like, to balance the equation, you're talking part of one side.
I was not talking. I'm not sure. Oh God, it's not
I got -9. How did you get it? You check it. You guys are wrong.
I don't know.
Check your math.
My check is
That's not right. That's 1.
It's not one. You said it's a word in my check. What was yours now? It's still
Minus 4 is 4. Minus 7. Oh, shit.
Settle down. Okay. It's 4. I got 2 equals -2. Yeah.
Okay. So guys, I think we're in a pretty good spot right here. Like before, I do want to show you how this one works. This could be, so I'm looking around, like Colby, Anders. You guys are going to want to hear this because you guys have definitely made a mistake here. Something kind of leading up to at the very start. So guys,
Listen up.
I really want to help you. I really want to make sure we're all solid here. So just listen. Just take a minute. Isn't squaring both sides kind of the common new strategy? Haven't we done that a ton?
Yes.
Before you do that, you need to get the radical by itself. So if I were to do this right here, what I'm writing is actually mathematically valid, but it's going to create a mess. And what it's not going to do is it's not going to get rid of any radicals. It's actually going to make it more of a mess than it is right now. So I'm not going to do anything like that. What I'm going to do is this. I hope you're listening. Before I try to square both sides or square anything, to be honest with you, I need to get the radical expression all by itself. The way that I do that is to add 7 to both sides. When I add 7 to both sides, I get square root of 6 minus 2x equals negative 2. And now that the radical is by itself, now is when I square both sides. So I will square the left side, and I will square the right side. The radical and the square do cancel out now. 6 minus 2x is equal to positive 4. And then the final goal here would be to get the x by itself. So it's going to be minus 6 on both sides. That gives me negative 2x equals negative 2. And we divide by negative 2 on both sides. And that gives me x is equal to positive 1. So this would be one of those spots where you might say, man, I did a good job, didn't make any mistakes. And that is true. But you have not checked. And of course, if you do check this one, you actually find out that the only solution we came up with does not work. And so I'm going to write this out here. My check in my original would look like this. Square root of 6 minus 2 times 1 minus 7 possibly equals negative 9. So 6 minus 2 is 4. So I get this. And the square root of 4 is 2. And here's where I can clearly see I've got an issue. 2 minus 7 is negative 5. And negative 5 definitely does not equal negative 9. So because the 1 did not actually make the equation true, we have to go back over here and say, you know what, that didn't work. Since the only thing I came up with didn't work, the answer is there is no solution. Okay, that makes sense? A lot of you did a real nice job with that. I think there's a few little details we need to continue to work on. So what I'm going to do now is I kind of want to assess where you're at with the last one we did yesterday. It was the toughest one, and so I want to see how this all goes for you. So please check this one out. All right, ready, go. There are plenty of folks that maybe there's a little gap in there somewhere. Maybe there's a little bit of a lack of understanding, and I'd like to try to help you with that right now. Okay? So I think step number 1, I think we all were pretty successful. You want to get the radical by itself. To do that, you need to add x to both sides. So when I do that, I end up with this. Square root of 3x plus 7 is equal to x plus 3. You could write it as 3 plus x, but I feel like this is more of a standard way of looking at it. Once you have done that, you got the radical by itself. Now is when you can square both sides. So I'm going to square the left side, and I'm going to square the right side. And this is where error number 1, or common error number 1, came into play. So the left side, the radical and the square just cancel out. You're left with 3x plus 7. And then this was an error that was made by plenty of folks. They wrote the right side down as simply x squared plus 9. Remember what squared means. Squared means the base times itself. And so that means you can't really distribute the squared across a sum. So instead of doing that, so Anders, that was it right there, right?
Yep.
So instead of doing that, what we're going to do is expand this out. Colby, come on, man. X plus 3 times x plus 3 is really what that means. So I'm going to expand this now and FOIL. So it'd be 3x plus 7. The foiling ends up being x squared plus 6x plus 9 once you've completed that FOIL. And now something new emerges, right? Now this looks like a quadratic, and that is exactly what it is. So in order to handle a quadratic, we need to be in standard form. So that means everything on one side equals 0. So I'm going to subtract the 3x from both sides, and I'm going to subtract the 7 from both sides. That is going to give me 0 equals x squared plus 3x plus 2. Now what do I do with this? I need to factor it. It's quadratic. The only way we've learned how to deal with this so far is to factor. And there are other ways. We'll learn them later. But for now, we're going to just factor this. Using your magic x, your split the b idea, this factors as x plus 1 times x plus 2 equals 0. And now what I'm going to do is set these equal to 0 and solve using the 0 factor property. So this would be x plus 1 equals 0. This gives me x equals negative 1. And that's one answer. And then x plus 2 equals 0. That gives me x equals negative 2. That gives me my other answer. What you would now do is you would check, right? You'd plug in the negative 1 back into the original up here, and you'd find that the negative 1, I believe, works out just fine, doesn't it? You do the same thing with the negative 2, and I think that one also works. So both answers are true. So we confirm that negative 1 and negative 2 are both solutions to that original equation. So, any follow-up questions?
Can you check them?
Sure.
Can you check negative 2?
Sure. So if you check negative 2, it would be square root of 3 times negative 2 plus 7 minus negative 2 equals 3. So this would be negative 6 plus 7 in there, plus 2 equals 3. This is square root of 1 plus 2 equals 3. 1 plus 2 equals 3. Check. Is that good? Is that what you're looking for, Sarah? Yeah? Any other follow-up questions? Okay. I'm pretty encouraged by that. I think I thought you did quite well. Let me give you another one kind of like that and see how this one goes. Okay?
I like maybe a foot taller than you. But he is still probably taller.
Okay, you ready to go? We'll be done with this soon. So I want to present this as kind of the issue that we have to deal with. In all of the examples that we've done yesterday and what we just did here for pretty much the whole class today, every single one of them was really the same in one key characteristic. They had exactly one radical in the equation. So if you notice here in number 7, this is a little bit different in that it has 2 radicals in the equation. And so you might think that we're going to deal with this a little bit differently. In a sense, we are, because we can't get the radical by itself because there's 2 of them, right? So here's what we're going to do. We want to make sure that one radical is on one side and the other radical is on the other side. And that's kind of where this stands as is, right? Once you've got one radical on one side and the other on the other side, we are going to proceed with that squaring both sides step to get rid of the radicals. So this is going to proceed a little bit differently, though. What I'm going to do is square the left side, and I'm going to square the right side. This should feel really familiar. You've been doing this a lot here today and yesterday. On the left side, I think it's going to be a pretty simplistic thing for us to think about. The radical and the squared are going to cancel each other out. How is the right side different from the left side?
There's a 4.
The 4, right? So it would be fair to say that the squared cancels out the square root, right? But doesn't the squared also apply to the 4? It applies to both. So 4 squared is 16. The square root has been canceled out. That leaves us with x plus 5, right? The radical has been canceled out. Keep in mind that it's 16 times the whole expression. And so what comes next, you're right, is the distributive property. So this 16 will get distributed across that. So I end up with 63 minus x is equal to 16x plus 80. And what follows is a pretty standard type linear equation that we've done before. What would you guys do as a first step? Minus 63, all right, so that's a good step. So if we do minus 63, it's negative x equals 16x plus 17. Okay, so what would, really the next step has to be very specific.
Plus X.
Okay, that, one of two ways, that'll work. So if I add x to both sides, I go with, this is sometimes, I'm actually really glad you said this, Sarah, because sometimes this is where we run into issues. What's 16x plus x? 17x plus 17. I haven't made any arithmetic errors, but I've made a very bad strategic error. What have I done or not done?
Put everything on the same side. You haven't got the x by itself.
Come on, there's something, maybe it's left.
0.
Okay, 0 and,
We've gotten rid of the equal sign.
I totally lost the equal sign. You see it? You should be way uncomfortable with what I've got up there because my equal sign gone. It's not okay. It's an equation. So you see how Anders, have you ever been on this one before? And you're like, the left side just adds out and you're like, oh, no more equal sign. You know what I'm talking about?
Yeah.
It can be really confusing. So it'd be 0 equals.
Yeah.
So now what do I do?
Subtract one of the two.
Subtract what?
One of the two. Okay.
Yeah. So maybe we subtract 17 over. That gives me negative 17 equals 17x. And now we're in our comfort zone, right? What do we do now?
Dividing 17.
Dividing by 17 gives me an answer of negative 1 equals x. So as you know, we got to check these. So I'm going to check this one real quick and see how it goes. It hopefully goes well. We'll see. So it'd be square root of 63 minus negative 1 equals 4 times square root of negative 1 plus 5. Just putting a negative 1 wherever I see an x. 63 plus 1, right? That's 64. So square root of 64 equals 4 times the square root of 4. What's the square root of 64?
8.
And what's the square root of 4?
2.
Look at that. It does check, right? 8 equals 8. So that checked out just fine. So I would say that x equals negative 1 is a legitimate solution for this. Okay? Take a minute, think that over. Do you have any questions? All right, great job today. Happy weekend. See you Monday.